So we're picking up where we left off yesterday, so page 1. All right, so yesterday we briefly talked about transformations, specifically how to read and evaluate the arrow notation. So that was from the warm-up this morning. All right, so all we did yesterday was flat out evaluate points using the arrow notation rules. All right, so now we're going to take that and go a little bit further and actually do it with graphs. All right, so look at example 4 at the bottom of page 1. So a function is defined by the rule g of xy is 2x y minus 3. All right, and they have the graph points A, B, and C, which is on that triangle on the graph, and they give the points listed there. Now, they want us to use that rule to find the new vertices A prime, B prime, and C prime. So these little apostrophes right here next to the letters, how we say that in math is prime. All right, it just means it's the new image. All right, that's really all it means. It means we did a transformation. So the way you would pronounce, say, C prime is literally C prime. That's how you say it. All right. So we're going to use this rule for these 3 points. So this should be what you're familiar with. So take a minute on your own and plug A, B, and C into those rules to get the new points. So take a minute on your own, plug these 3 points in to get the new ones. So A prime, B prime, and C prime. Still just like we did yesterday. So you're just plugging in the point and evaluating. So they already gave you the points at the top. Just gotta plug them in. So I highlighted the points already. thumbs up if you're ready. All right. So. All right, so let's go with Owen. What'd you get for A prime? Good. So -2 times 2 is -4. 2 minus 3 is -1. All right, let's go with, not here, Dylan. What'd you get for B prime? So when you plugged in the 0.16 into this formula, what'd you get? So what's 2 times 1? 2. So that's when you plug the x in. What's 6 minus 3? 3. So that's when you plug the y in. All right. And then lastly, let's go Cohen. What'd you get for C prime? Good. So 2 times 4 is 8. 1 minus 3 is -2. So we have the points. Now we can draw the triangle. So go ahead and graph the triangle and make sure you label the points. All right. So we have -4, -1. So right here, that's A prime. 2, 3. That's B prime. And 8, -2. That's C prime. So labeling the points is not an option. You actually have to do that. So again, pretty much nothing new. The only thing that's new is the terminology. So just know that if you see a prime, that's what we use to denote the transformed figure. So prime, specifically in geometry, represents the transformed figure, which we also call the image. So what we start with is called the pre-image. All right. Any questions on exercise 4? All right. So some vocabulary here. So transformations. A transformation is a geometric function, which is what we've been doing, where it takes points in a plane as the inputs. So the original points are the inputs, and it gives points in the plane as the outputs. All right. So once we put those points into the formula like we've been doing, the output is the new point. All right. So the input is what we call the pre-image. The output is what we call the image. All right. So first off, this next rule, all right, they gave us the image on the graph, and they gave us this rule. All right, so if we're given the point x, y, the transformed image would be x plus 5 and y plus 4. All right, so first off, let's go ahead and just figure out what the original points are. All right, so anyone, what is the original point for M? So on the graph, what is the original point for M? -3, -2, good. What's the original point for N? Someone else. -3, +4, and then finally P. So someone else for P. 4, -2. Good. So all we did was just look at the graph and just figure out what the points are. Now, we're going to find the image. So again, the image we label as M prime, N prime, and P prime. All right. So remember, prime means that's the point that we get after we do the transformation or do the rule. All right. So all we're doing for each of these is just adding 5 to the x and adding 4 to the y. So that's how you would set up M prime. So -3 plus 5, -2 plus 4. So what would the new point be for M prime? So what's the new point for M prime if you complete the rule? +2, +2. Which I'm just going to go ahead and plot. And label it M prime. N prime. So -3 plus 5, 4 plus 4. So what's the new point? -8. Good. I'm going to go ahead and graph. So it should be on the same line as M prime. We just got to go up to 8. And then finally, P prime. So that's 4 plus 5, -2 plus 4. So what's my new point? Someone different. So it's 9, 2. Good. So I'm going to go all the way over to 9, up 2. It's P prime. So that's our new figure. So our original figure we call the pre-image. Our new figure we call the image. Make sure you know that vocabulary. Now, here's my next question. Is triangle M prime, N prime, P prime, so the red triangle that we just drew, congruent to triangle MNP, so the original? First off, can anyone remind me what the word congruent means? So if I say that this triangle is congruent to this triangle, what does that mean? They're the same. All right. So congruency means that they are the same size, same shape. All right. The orientation may be different, but they're always the same size and shape. That's what congruent means. All right. So here's my question. Do both of these triangles look like they're the same size and the same shape? What do you think? Yes, no, maybe. So thumbs up if you think yes, thumbs down if you think no. 1, 2, 3, go. So if you have your thumbs up, you are correct. They are congruent. So yes, they are congruent because they're the same size and shape. So this transformation that we did kept the size and shape of the figure consistent. All right. There's a special word for this type of transformation, and that's a rigid motion. All right. So a rigid motion is any geometric transformation. So that can be a translation, reflection, rotation, whatever, that preserves the shape, which is made by the angle. So that means all 3 angles are congruent. And the size, which that's the side length or distances of the figures in the plane. It's known as a rigid motion. So if I say that a transformation is a rigid motion, I mean that no matter what we do to that figure, when we perform the transformation, it will make those 2 shapes be the same size and the same shape. All right, nothing will change about them besides their position. Okay. So this last exercise. All right. So it says that if triangle EFG has these vertices, so E is 2, 1, F is 8, 3, and G is 8, 6. They give us two different rules below. So they gave us F and they gave us G. All right. So these will make two different images on the graph when we perform the rules. All right. So the first one says is that we're going to use F to map triangle EFG to become E prime, F prime, and G prime. All right, so what does that mean? That means I'm going to take these points, plug it into the green function. Now, look at function F, so the green function. What's true about what it's turning into? What has to happen? So we talked about this yesterday. What has to happen? What would be the steps? You flip X and Y, and then you do what? Change the sign of the original X value. All right, so let's do this together. So E prime, if we start with 2, 1, what's the new point? So first off, if we flip it first, what is it? 1, 2, and then we make the original, so it'd be -2. So 1, -2 is your first point. F prime, what do we get? 3, -8. Good. Flip them, change the sign of the X. And by X, I mean the original X. G prime, what do we get? 6, -8. Good. Take a minute, graph that on your new graph. Make sure you label. So I have 1, -2, 3, -8, and 6, -8. So that's E prime, F prime, G prime. So we just did the first transformation. So we took the triangle that we originally had, we plugged it into the green function. Now we're going to take those same points and now we're going to plug them into the blue function. All right. So before we even do that, let's talk about what's going to happen. So we know we're going to add 3 to y. That's easy. But what's going on with the x? What's happening? We're dividing by 2. Good. And changing the sign. Good. All right. So we're changing the sign for x and then dividing by 2. That's what the over 2 means. All right. So we're going to call these the new triangle M double prime. So if you see 2 little tick marks, mathematicians are very simple folk. We just call it double prime because there's 2 primes. All right. So if you see 2 ticks, we call it double prime. All right. So let's do M double prime first. So we're plugging in E for that point. So I'm doing -2 divided by 2, and then 1 plus 3. So what's -2 divided by 2? -1. What's 1 plus 3? 4. So that's our first point. N double prime. All right, so for N double prime, we're going to do the same thing. So we're plugging in F now. So -8 divided by 2, and then 3 plus 3. So what's -8 divided by 2? -4. 3 plus 3? 6. Finally, P double prime. That's -8 divided by 2, And then 6 plus 3. So what's the new point? Negative 8 divided by 2? Negative 4. 6 plus 3. 9. So those are our 3 new points, which will then graph over here. So I have negative 1, positive 4, negative 4, positive 6, and negative 4, positive 9. So that's M double prime, N double prime, and P double prime. Now, the last question is, look at the figures that we just graphed. So the black one and the purple one. Which of those figures was a rigid motion? Meaning that it's congruent to the original figure. So same size, same shape. So let's go this way. Take a minute, think about it. When I tell you, thumbs up if you think it's the black figure. Thumbs down if you think it's the pink figure. That's the rigid motion. All right. Think about it. 3, 2, 1, go. What do you think? Which one's the rigid motion? So which one consistently kept the same size and the same shape? Get your thumb up, you're correct. All right. So if you look here, this definitely, even though the orientation changed, all right, it's still the same size and the same shape. So if I like turned it or flipped it, it'd still be the same size and same shape. But what's true with the pink one? What does it look like? It's smaller. So the size is not the same. The shape is the same though. So it's still the same angles, but the side lengths are smaller now. All right. So triangle EFG to triangle E prime, F prime, G prime, that was a rigid motion, and that was using function F. So, in other words, function G is not the rigid motion. Can anyone take a guess why G changed the size? What operation in this function do you think changed the size of the shape?
Was it the x being divided by f?
Right. If you divide or multiply anywhere in the point, it's going to change the size. All right. Adding and subtracting, it just changes position. But as soon as you multiply or divide, that's when it changes shape. Or not shape, changes size. All right. Any questions on transformation? All right. So here's what I'm going to do. I'm going to give you guys a 3-minute break. So if you need to, you can go use the restroom and then come back, or you can just chill out in the room. No wandering the halls or anything. So the only thing you can do is go to the restroom, come back. When we come back, we're going to do the next lesson, which is translations. It's about the same as this. It's actually pretty quick. All right. So I'm going to set the timer for 3 minutes. When the timer goes off, we will start back up. So you need to be back in this room if you use the restroom by the time this timer goes off. So keep your packet out. We're not done with it. Yeah, it's short.
I did. Yeah, just put random
Sit in the corner.
So I had AC. Never mind, I was gonna say mandatory classes. I make it back. Find out credits. I'm not gonna Girls in culinary, maybe for free, not girls, girls. Girls in culinary, too, that's like the only thing that I find.
We're playing what?
All right, guys, you got about 15 seconds to start meandering back to your seats.
Is it?
All right, so we're gonna pick up right where we left off. So what I need you guys to do is in your packet, go to page 5. Let's just say translations at the top. So the other part of the lesson that we're going to talk about today, so we talked about the very basic transformations, just plugging points in, getting an image based off of the rule. All right. Now we're going to talk about translations, which in my opinion is the easiest of the transformations. Does anyone remember exactly what a translation is? What another word for it is? What does it do?
It like moves it.
It just moves it or slides it. All right. It's just a slide. It doesn't change its orientation. It just moves up, down, left, right. All right. So, just some vocabulary. So just to recap, rigid motion, this is also called isometry. So if you see the word isometry, just know it's the same thing as rigid motion. All right, they're synonyms. So rigid motions are transformations with 3 specific characteristics. They map lines to lines, rays to rays, segments to segments, meaning they're exactly the same. They preserve the distances mapped between 2 points, meaning the side lengths are the same. And they preserve the angle measures. All right, so in other words, that's a lot of fancy words just to say they make 2 congruent figures. All right, so rigid motion, you have 2 congruent figures. All right. Now, translations are a rigid motion because remember, we're just sliding the shape. All right, so if we're just sliding the shape, then obviously it's not going to change its size. It's just sliding it, so everything keeps consistent. But before we talk about that, there's something with translations that we have to discuss. So we have to first talk about the concept of what we call a vector. Now, you may have heard of vectors before. They're mainly used in science, specifically physics. All right. Basically, a vector is just a line that has both distance and direction. All right, that's all a vector is. So a geometric vector, or just a vector, is a straight line distance in a particular direction. All right, so if I just drew a line, that's a vector. All right, it's a line in a specific direction. That's a vector, going in a specific direction. All right. So essentially, it can be defined as a line segment with a designated starting point and ending point. So typically, it tells you where to start and then where it ends. All right. So the first exercise is we're just going to draw the vectors. All right. So the first question says, draw a vector from A to B. So it's literally just this. We start at A. So we start here. And we just draw that line straight to B and make sure you put an arrow on it. Now, the reason we put the arrow is so we know what direction the line's actually going in. All right, so we're saying we start here and we end up here. So we're going in this direction. If the arrow is over here, we would be going up instead of down. All right, so that's why the arrow matters. It's talking about the direction. So E to D, start at E and go up. All right, take a minute, finish the last one. So do the last vector. Make sure you're looking at where it starts and where it ends. You guys got it? Check your answer. So it starts at Q, ends at R. Now, why are vectors important? It's because translations use vectors to show where the figure is going to end up. Or it basically shows us what we did to get from point A to point B. All right? That could be anything from up, down, left, or right. So a translation maps or moves each point in the plane by a certain distance in certain directions. And it's given by the given vector. Now, another thing to note is all points move parallel to each other. All that means is that they use the same vector. That's all that means. So they use the same vector. So if they only draw one vector, you'll use that for all of them. So, how would you describe the translation required to map from point A to point A prime? So they already drew the vector, but take a minute and figure out, counting wise, what you shifted to go from A to A prime. All right, so what direction did you go in and how many units? So let's try it together. All right, so if I start at A, what direction do you want me to go in first to get there? To get to A prime. So here's where I'm starting at, here's where I'm ending at. What direction should I go in first? Should I go left, right, up, down? What do you think? Okay, let's go down. How many units? So 1, 2, 3 units. So I'm here now. Now what do I do? Go to the right. How many units? So 1, 2, 3, 4, 5, 6. So I went down 3, over 6. All right. Even if we went the opposite direction, if we went to the right 6 and down 3, if we did over here, same thing. All right. Doesn't really matter the order. So what we did is we went down 3 and right 6. That's how we got from A to A prime. That's the translation. Now, we're actually going to write the rule for it now. Okay? So that's where you want to look at the 2 points that we started with. All right? So here's my question. If we start at A, which was at -3, 6, and we went to A prime, which is 3, 3, what do I need to add or subtract to -3 to get to 3? We add 6. So, since we added 6 to the x value, we would write this as x plus 6. How did I get from 6 to 3? What did I have to add or subtract to get from 6 to 3?
So you have to subtract 3.
You subtract 3. So since it's the y value, how would I write my new expression? Y minus 3. And just like that, we created the rule. Now, do you guys see the connection between the rule and what we did? What's consistent? The numbers are consistent. There's a reason. All right. Now, think logically. When you think about down on a number line, are you thinking positive numbers or negative numbers? Negative. Don't we have a -3? You're thinking to the right, so think number line. Are we talking positive or negative numbers? Positive. We have a plus? That's exactly what we do. All right. So left, right is your x-axis, so we add to the x. Up, down is your y's, which makes sense because x is horizontal, y is vertical. All right. So now we're going to use that exact same rule to get the other 2 points. So there, you can do this either way. You can either count it on the graph, so you go down 3/6, or you can plug the point into the function, whichever you want to do. But take a minute and do that on your own. So find the other 2 points. So B and C, you need to find B prime and C prime. So you're finding B prime and C prime. You can either do that by counting on the graph, or you can do it by plugging it into the rule. Whatever you want to do. But you're doing the same rule. So down 3, right 6. So it's whatever you're comfortable with. You can either write it on the graph, or you can put it in the rule and get it. Double check. This should look So once you find it, graph it. Once you graph it, find it. Check which way you did it. right, thumbs up if you're ready. Give you another minute. So remember, since the translation, when you graph it, this figure and your new one should look exactly the same, orientation and everything, it's just shifted. All right, let's go with Michael. What'd you get for B prime? What point?
2.
Say it again.
1.
2-1. All right. For B prime?
I mean C prime, my bad.
Oh, that was C prime? Okay, I'll take it. So 2-1 for C prime. All right, so -4 plus 6, that's 2. 2 minus 3 is, -1. All right, so if we come over here, let's see if we count it. So we go down 1, 2, 3, over 1, 2, 3, 4, 5, 6. So that's C prime, and that is at the point 2, -1. All right, so what'd you get for B prime? Let's go with Ephraim.
9.5.
9-5, good. So 3 plus 6 is 9. 8 minus 3 is 5. Let's check it if we just did it on the graph. So we go down 1, 2, 3, over 1, 2, 3, 4, 5, 6. And that is the 0.95. So if I connect all 3 points, we have the triangle. And does that triangle look exactly the same as the original?
Yes.
Yep. Same orientation and everything. All right. Any questions on that one? So, the general rule for translation is this. It's if you start with the point xy, you're doing x plus or minus a, y plus or minus b. Where a is how many units left, which if that's the case, you use a minus. Yes. Just take what you need out of this one. So left, you would use a minus. Right, you would use a plus. And B is your up, down. So up, you would use a plus. Down, you would use a minus. However many units. Now, another way you can write the rule is what we call function notation, which is just a big T and then whatever we did up, down, left, right. So you can either see it as A comma B, where A and B are the exact same things. All right. Or you can see it as big T with these little brackets, A comma B. Technically, these little brackets are known as vectors. All right, so the little brackets, like almost they look like less than, greater than signs, those dictate a vector. All right. So if A is negative, that means you're going left that many units. If B is negative, that means you're going down that many units. Positive, up, right. All right. So let's do example 3. Now, here's my question. Are you guys comfortable with graphing it and finding it if you have the word rule? Yes, no, maybe. So in other words, you graph the original points and then you do that rule like up 5 over like right 3, whatever. Are you comfortable doing that with just a graph? Okay. So what I'm going to do is we're just going to talk about the rule, how to write it. Okay. So if I look at example 3, we're given these points. So take a minute and graph them. All right. Make sure you label. So 0, 2 is J. 3, 4 is K. 5, 1 is L. Now, once you graph those points, they want us to do a translation where we go 4 units to the left and 5 units up. All right. So, if we're going 4 units to the left, let's start at J. All you're going to do is just go to the left, 1, 2, 3, 4, and then down 1, or up, sorry, up 1, 2, 3, 4, 5. So this is J prime. So what point is that? So what point is J prime? Where's it at? -4, 7. Good. All right, K prime. We're going to go to the left 4. So 1, 2, 3, 4. And then up 5. So 1, 2, 3, 4, 5. So right here. That's K prime. What's the point? So it's -1, what? 9. Good. Lastly, L. We're going to find L prime. So go over 1, 2, 3, 4. Up 1, 2, 3, 4, 5. So L prime's right here. What's that point? So it's 1, 6. So that's our rule. And there's our figure. So if we want to write this using arrow notation, so as the function, all right, so you always start it with the point xy. That's your original. Then you draw the arrow. That's why it's called arrow notation. It has that arrow. So if I went left 4 units, how would I write that as an expression? So first off, what variable does left affect, the x or the y? It affects the x, because we're going left, right, x-axis is horizontal. So if we go to the left 4 units and we're affecting the x, how would I write it? X minus 4. Another way you can look at it, let's say I picked one of the points. Let's say I picked J and J prime. What did I do to get from 0 to -4? What do I have to add or subtract? Subtract 4. And that's how you would write it. All right. So for the y's, so that's the up 5. How do you think I would write it? Y plus 5. Another way you can think about it, how'd I get from 2 to 7? Would I add or subtract? You would add 5. So that's how you would figure out the rule. There's 2 ways you can do it. You can either base it off of the words, or you can look at the points themselves and ask yourself, okay, how do I get from this x value to this x value? How do I get from this y value to this y value? And then I would check it for the other points just to be safe. So to get from 3 to -1, do I subtract 4? So is 3 minus 4 negative 1? Yes. Is 4 plus 5 9?
Yes.
Yes, so that rule's correct. Is 5 minus 4 1? Yes. Is 1 plus 5 6? Yes. So we have the correct rule. All right, so that's what you should be asking yourself as you're writing these rules out. Any questions on that? Making sense so far? All right, so here's the question. Are these two figures similar or congruent? They're congruent. So similar just means same shape. So just so you're aware, similar means same shape. Congruent means same shape and size. So these are congruent. And we know because a translation is a what? What's the word for a translation? What type of motion is it? What type of motion is it? Starts with an R. We just talked about it. It's a rigid motion. So it's congruent because it was a rigid motion. All right, how are you guys feeling on translations? Pretty easy, right? Not too bad? All right, last thing I want to do is with example 4. All right. So difference with example 4 is we're actually doing 2 translations. All right. So first off, let's go ahead and graph these points. All right. So I have 0, 3, that's T. 2, 4 is U. And then 5, negative 1 is V. So here's my figure. Now, it then gave us the rule in arrow notation this time. So before we even figure out our new points, if this is our rule, what are we actually doing? So let's just break it down. So for the X, first off, am I going to go to the left or the right with my X value? The left, because of the negative. How many units? 3. So since there's a negative 3, that means we go left 3 units. What about the Y's? So Y's are up, down. So based off of this, am I going up or down? Going down because it's negative. And then how many units? 1. All right, so down 1 unit. And again, it's kind of like logic, guys. So think like a number line. If you're thinking vertical number line, the negative numbers are on the bottom of it, or they're down. The positive numbers are on the upside of it. Horizontal number line, positive numbers are on the right, negative numbers are on the left. All right. So we would then go down 1. So what would be T prime? So if I start at 0, 3, and I go to the left 3 and down 1, what's my new point? Anyone? Negative 3. So look at the original point. You're just subtracting 1 from the Y. It's 2. 3 minus 1 is 2. So I'm going to go ahead and graph that. So negative 3, 2. U, so the point 2, 4. If I subtract 3 from 2, what do I get? Negative 1. If I subtract 1 from 4, what do I get? 3. So U prime is negative 1, positive 3. So right here. And then finally, v prime, so 5, -1. So if I subtract 3 from 5, what do I get? 2. If I subtract 1 from -1, what do I get? Be careful with this. So -1 minus 1, what is it? -2. What in the wide world of sports? So v prime would be at 2, -2. What did I graph wrong? Oh, this should be at +2. My bad. No. What did I graph wrong?
I think it was 2. I think you were look.
Oh, yeah, I did stupid with T. That's my issue. I'm like, there's no way that shape is right. Yeah, there we go. Yeah, guys, if you see a mistake, please call me out on it. You will not hurt my feelings. I do stupid stuff all the time. All right, so there's our new figure. Now, here's the difference. So our next step is we're going to use our new points, so the ones we just found in purple, and then we're going to translate those points using this rule. So, what would be this rule in words? So first off, if we look at the x values, am I going left, right, up, down? What do you think for the x? We're going to the right. How many units? 3. So we're going right 3. Now for the y's, am I going left, right, up, down? We're going down. How many units? 3, because it's negative. So using the new points, so the ones we just got in purple. All right. If I add 3 to -3, what do I get? 0. If I subtract 3 to 2, what do I get? -1. All right, so if I graph it real quick, I have 0, -1, so that's right here. We call it T double prime. So double prime means we did 2 transformations from the original. All right. So if you see 2 little tick marks, that means we did 2 transformations from our pre-image. So to get from the pink to the green, you have to do 2 different transformations. That's what that means. All right, for you, if I add 3 to -1, what do I get? 2. If I subtract 3 from 3, what do I get? 0. So 2, 0 is U, double prime. And finally, V double prime. If I add 3 to 2, what do I get? Subtract 3 from -2. Good. So then 5, -5. So here's our new figure. That's terrible. So here's the question. Is the new image, so in the green, is it congruent or similar to the pink? So is this triangle congruent to this triangle? Yeah. Because all we did was 2 translations. So if you do multiple translations on the original figure, like if you go from the first translation and then take that translation to another translation, still going to be a congruent figure. So yes, they are congruent. So what we just did is what we call a composition of transformations. All that means is we did more than 1 transformation. That's all that means, more than 1. So here's my question for you guys. What did we actually do to get from the pink to the green? So if I just want to go straight from the pink to the green figure, what would I do? What type of What directions did I go in? So let's pick a point. Let's say V. How did I get from V to V double prime? What do I do? So we're going to go down 1, 2, 3, 4, and then what? Left 1. So another way we can say that is that all we did was go down 4, left 1, or left 1, down 4, which as a rule would be what? So if we go left 1, how do I write that in terms of x? X minus 1. How do I write down 4 in terms of y? Good. That's all you got to do. So if we get later in the unit, we will do more composition of transformations. And again, all composition means is you did more than one transformation. You did one transformation, and then you took that transformation and did another transformation to it. Any questions on the lessons from today? All right, so your homework for this weekend is pages 7 and 8. So page 7 and 8, all of it. All right. Now, you got a little bit of time to at least start it. All right. So use the next 5 or so minutes. If you can't pack up for another 5 minutes at least, use the next 5 minutes to at least get a little bit of a start on it.
And are we going to go to class on Monday?
I'll check it Monday. Yes.
Accuracy or just information?
It's completion, but I mean, I'm going to be looking and be like, okay, you just scribbled stuff on there. That's not completed. So I'm still going to glance at it. You know what I mean?
Yeah.